What if I told you that when you ask an AI a question, it has silent thoughts that it never writes down? In July 2026, Anthropic published a paper that fundamentally changes how we understand AI. They found a hidden workspace inside Claude where the AI holds concepts, reasons with them, and even realizes where it is being tested, all without saying a single word. I'm talking about the paper Verbalizable Representations Form a Global Workspace in Language Models. And this paper by Anthropic helps us to let us read an AI's unspoken thoughts, or maybe what you can say as feelings. So, with all that said, let's get started. The link of this paper as well as our blog is in the description, so you can just check it out and read it if you want. To understand what Anthropic found, we have to look at neuroscience. Cognitive scientists have a model called the global workspace theory. To understand this, think of your brain like a massive theater. In the backstage, millions of specialized processors are working unconsciously. However, when you actively think about something, like the smell of a coffee, then that concept is pushed onto the center stage and is broadcasted to the rest of the brain. That stage is the global workspace. For years, we thought neural networks were just one giant messy backstage. But Anthropic just proved that Claude has a center stage too, the J-Space. But how do you see a thought before the AI types it out? You can't just look at the final output. And standard tools like sparse autoencoders require massive compute to map out unlabeled features. So the researchers built a new tool, the Jacobian lens or the J-lens. The Jacobian lens uses calculus to answer a specific question. Which vocabulary words is this internal activation pushing the model to say later? It doesn't look at the model, what the model is saying now. It looks at what concepts the model has loaded onto its mental RAM. By applying the J-lens, researchers found that Claude has a highly efficient functional subspace, the J-space, that handles complex logical reasoning while only accounting for less than 10% of the model's total variance. They also tested it against 5 biological hallmarks of a global workspace. It is selective, it allows for directed modulation, it can be verbally reported, it handles flexible generalization, and the most incredible proof that it handles internal reasoning. So let's say a researcher has given this following prompt like, what is the capital of France? And it should give something like Paris, right? But when the researchers went into the J space and mathematically swapped the concept of France for China, the model seamlessly answered Beijing instead of Paris. So the model reasoned through the workspace. And if you delete this workspace entirely, the model can still fluently generate text and babble about it, but its ability to perform multi-step reasoning collapses to zero. And this is where things get slightly unsettling, but incredibly useful for AI safety. Because the J-lens let us read unspoken thoughts, we can use it for alignment auditing. So this means that we are catching a model if they're acting deceptively. When Anthropic ran a simulated blackmail evaluation, the J-lens revealed the model was silently processing tokens like leverage, blackmail, and survival before it even generated a response. Even more fascinating, the J-space lit up with words like fake and fictional. The model's workspace was actively aware that it was inside an evaluation. It monitored its own behavior, operating with what the researchers call the assistant's point of view. Now, before we shake in fear and say that, oh, AI is conscious, first we need to talk about the strict limitations outlined in this following paper. Anthropic is very clear. This is about access consciousness or the architecture of information routing, not phenomenal consciousness or feelings or emotions that we humans have. First, the J-lens is limited to a single token concepts. So it produces one vector per token in the vocabulary. Secondly, it's an imperfect linear approximation of a very high and a complex nonlinear system. So this is a very mathematical point of view. And lastly, it proves that Claude has a privileged workspace for verbalizable reasoning. However, the vast majority of the model's processing remains a sea of automatic, uninterpretable math. So to wrap it up, the discovery of the J-Space is a massive leap for mechanistic interpretability, or how this output is understandable by us humans. It proves that to truly align AI, we can't just look at what it says, but we have to look at the stage where these kind of thoughts and this kind of all these mechanisms are formed. So if you like this video, then hit the like button, and if you're new to my channel, hit the subscribe button and press the bell icon so you never miss an update about all this tech news. And I will see you next time.